Good morning students, welcome you all for next generation learning. Today we are going to see the subject physics, class 10, chapter number 13, magnetic effects of electric current. Topics: electric generators, domestic electric circuits. The first topic, electric generator. There are two type of electric generator. One is AC generator, the second one DC generator. The AC generator produce AC current, that is alternative current. DC generator produce direct current, that means DC current. So what is meant by AC current? If the current reverses direction after equal interval of time, it is called alternative current. If the current flows in one direction only, it is called a direct current. The first topic, AC electric generator, it produces AC current. This topic I already discussed in the last class, and this is a construction of electric generator. It consisting of rotating rectangular coil ABCD placed between two poles of permanent magnet. The two ends of these coils are connected to two rings R1 and R2. The inner side of these rings are made insulated. The two conducting brushes B1 and B2 are pressed separately on the rings R1 and R2. The two rings R1 and R2, internally attached to the axle. It is internally attached to the axle. The axle may be mechanically rotated from the outside. Outer end of the two brushes, the outer end of the brushes P1 and P2 are connected to a galvanometer to show the flow of current in the given external circuit. So you have to see this animation. When the coil is rotating in the magnetic field, the galvanometer shows deflection. So from this deflection we could understand that the current is produced in the coil. And see the direction of the deflection of galvanometer. It deflect this side also, left and also right. So the plus side and minus side. That means the direction of the current is changed alternatively. So it gives the alternative current, that means AC current. For first half positive, the next half it gives negative. These things already I discussed in the last class. The next one, DC generator. The DC generator produces the DC current, and this is a construction of DC generator. Here the rectangular coil ABCD, this is a rectangular coil ABCD placed between the two permanent magnetic poles, and the coils are connected to split rings P and Q, and there are the two carbon brushes X and Y. X and Y are connected to P and Q. Then X and Y are connected to galvanometer, and the split rings are placed. The axle is placed between the split rings. See here, the axle is placed between the split rings P and Q. So when the coil is rotated in the magnetic field, see this animation, the galvanometer shows deflection. So when the galvanometer shows deflection, we could understand that the current is produced in the circuit. That means the current is produced in the coil. But see here, the direction of the galvanometer is only in one direction. In AC generator, we have seen that the galvanometer shows the direction in both right and left. But here it shows only in one direction. So such type of current is called DC current. It produces DC current because the DC current flows only in one direction. So I hope you understood what is meant by the AC generator and the DC generator. In AC generator, we are using the two slip rings for getting for AC current. For DC generator, instead of slip rings, we have to use split rings like in an electric motor. And this is I already discussed in the last. The next topic is a domestic electric circuit, and you know that the electricity is very important, and every homes we have that electric circuit. In our homes we receive supply of electric power through a mains supply, also called mains, either supported through overhead electric poles or by underground cables. So how we are getting the electric circuit? We are getting the electric circuit from the electric pole or underground cables. By the two method we are getting the electricity we are getting electricity for our home. The one is from the electric poles and another one is underground cables. So there are the two, these wires are made up of aluminum or copper, and from this we are taking the electric current for our home. So one of the wire in this supply usually with red insulation, see here red insulation, and it is called live wire or it is a positive. And another wire with black insulation is called a neutral wire, that means it is a negative. So there are the two wires are coming from the electric pole to our home. The one wire is a red insulation, that wire is called a live wire or positive. And a black wire, another wire is a black insulation, it is a neutral wire, it gives a negative current. And live wire carries for the 220 voltage and neutral wire carries for the 0 volt. So this is a live wire and this is a neutral wire. The live wire carries the 220 voltage and neutral wire carry the 0 voltage. So the potential difference between these two wires are 220 voltage. 220 minus 0 equal to 220 voltage. It is a very important one mark. What is the electric potential difference between the live wire and a neutral wire in India? It is a 220 voltage. So the potential difference between the live and the neutral wire in India is 220 voltage. And this is a simple domestic electric circuit. I will explain this electric circuit one by one. And This diagram is given in your book. This is also I will explain. You know that from the electric pole, the two wires are, we are getting the two wires, the two insulator wires L and N. The L means live wire and N means neutral wire. It is coming from the electric pole and enter a box fixed just inside our house. In this box, a main fuse F1 is put in the live wire. See, this is an electric pole. From the electric pole, we are taken two wire. The one is live wire and then another one is neutral wire. And first we are connected the live wire with main fuse. This is a main fuse F1. The next, this fuse has higher rating, about 50 ampere. You know that the fuse have the different rate. The last chapter we learned that the 5 ampere fuse wire, 10 ampere fuse wire, 15 ampere fuse wire. For in this fuse wire has the rate of 50 ampere. The two line wires then enter into the electricity meter board. See, after fuse wire, the two wires, both the live and the neutral wires are enter into the electricity meter, which records the electrical energy consumed by us in the unit of kilowatt hour. The last unit we know that the electric energy is measured in the kilowatt hour. So that live and neutral wire are enter into the electricity meter board. The main fuse and the meter or both are installed. So this main fuse and the meter are both installed by the electric supply department of our city. We are not installed this main fuse and meter in our home. Who will install this? The electric supply department of our city. So up to this I explained that the two wires, live wire and neutral wire, the main fuse is connected to the live wire. Then the live and neutral wire are enter into the electricity meter board. Here the electrical energy is measured in the kilowatt hour, and these main fuse and meter box only installed by the electric supply department of our city. The next, these live and neutral wire, the two wire coming out of the meter. So the live and neutral wire are coming out from the meter box and are connected to the main switch. Yes, this main switch is to switch off the electricity supply when required. So when we want to on this electricity, using the main switch we can on. When we have to off, using the main switch we can off. So on and off switch are placed in the main switch. After the main switch, there is another fuse wire F2 in the live wire. We are connecting the fuse in the live wire. This fuse is called consumer's fuse. Do you understand? So up to this I explained that. Up to this I explained the live wire, the main fuse, the live wire, main fuse, meter box, then main switch, then consumer fuse. Both the fuse wires are connected in the live wire, not neutral wire. The live wire is a positive and the neutral wire is negative. it is very important to note here that usually there are the two separate circuit in our house. What are that? One is lighting circuit and another one is power circuit. The lighting circuit means we have to use 5 ampere fuse. In power circuit means we have to use 15 ampere fuse. So what is the uses of lighting circuit and power circuit? Lighting circuit is used for running low power rating devices such as electric bulb, tube light, fan, radio, TV. These are connected to lighting circuit because it draw only the small current. So the electric bulb also tube light, fan, radio and TV or draw small current from the main. And the other hand, the power circuit with the 15 ampere, where we have to use the power circuit with the 15 ampere. It is used for running high power rating devices. High power rating devices nothing but the electric iron, room heater, geyser, electric stove, refrigerator, because these electric gadgets are draw heavy current from the main. Do you understand? There are the two type of connections we given in the in domestic circuit. One is the lighting circuit and another one is power circuit. The lighting circuit means we have to use 5 ampere fuse. In power circuit means we have to use 15 ampere fuse. The lighting circuit is used for running low power rating devices and power circuit is used for running high power rating devices. And we will describe only lighting circuit with a 5 ampere fuse here. Here I discussed only the lighting circuit. So this circuit is a lighting circuit with a 5 ampere fuse. Each distribution circuit is provided with a separate fuse so that if a fault like short circuiting occur in one circuit, it is corresponding to fuse blows off but the other circuit remains unaffected. See in a main circuit is in this main switch we have the different distribution and each distributions are connected to fuse, because if one circuit is blow off, other circuit remains unaffected. Do you understand? In a main switch there are the different distribution and each distribution consists of a fuse wire, because due to the short circuit or overloading, in one circuit blow off means other circuit remains unaffected. We describe the wiring of our rooms. It is very important to note here that along with the live wire and neutral wire, the third wire called earth wire. See, this is a earth wire. Along with a live wire and neutral wire, the third one is earth wire, also goes into our room. See in this circuit. The live wire, neutral wire and earth wire. All the three wires goes into our room. Earth wire E has been shown in the dotted lines. See here, the earth lines are shown in the dotted lines. One end of the earth wire E is connected to a copper plate. See, connected to a copper plate and buried deep under the earth. This copper plate is buried deep under the earth near the house or nearest electric substation. So in every home there are the three wires or enter into our room. The one is a live wire and another one is a neutral wire. The third one is a earth wire. The earth wire is connected to a copper plate and it is buried deep under the earth. and the earth connection is first made to an electric meter. So here the electric meter is connected to earth wire and then to main switch, then the earth wire is connected in the main switch. This earth wire then goes into our room along with live wire, neutral wire, neutral wire. Please note that earth wire up to the main switch. So up to the main switch of our house is usually uncovered. You know that the live wire is insulated with the red plastic, and the neutral wire is covered with the black color plastic. But the earth wire is not covered up to the meter and main switch. But the earth wire which goes from the main, after the main connection, it having the green insulation covering it. So the earth wire have the insulation of green. So in order to distinguish between the live, neutral and earth wire, we having a red plastic cover for made up of live wire, black color for neutral wire and green color for earth wire. Do you understand that? The earth connection is first given to meter box and main switch, and this earth wire is connected to the copper plate, and the copper plate is buried into the ground. Up to this, the earth wire does not have the insulation, but when it come out from the main switch, it have the insulation with green, live wire with red insulation and neutral wire with black insulation, earth wire with green insulation. For identifying the wire, we are giving some insulation. And how to connect the bulb or socket? You have to take the one wire from live connected to one end, and the other one more wire is getting from the neutral. The one is positive and one is negative. See, so when the switch is closed, the positive and negative. So the wires are connected to positive and negative. So the bulb will glow. The same as how to connect the electric socket. The one from the live wire and another from the neutral. One is connected to earth. So when the circuit is closed, this is a positive and this is negative. So the circuit is a closed circuit. You know that electric fuse is a very important component on all domestic electric circuit. A fuse is a fuse in a circuit prevents a damage to the appliance and the current due to the overloading and short circuit. What is the uses of fuse? The fuse is a very important component in all domestic circuit because it prevents damage from the appliance from overloading and short circuiting. What is meant by short circuit and what is meant by overloading? The short circuiting is nothing but if the plastic insulations, you know that the live wire and the neutral wire, earth wire have the insulation, and the insulation are made up of plastic. So if the plastic of insulation of a live wire and a neutral wire gets torn, and see this is shown in the image. Here the insulation is torn, then the two wires touch each other. So when the insulations are torn, the two wires are touching each other. This is a live and this is a neutral. When the insulation cover is on, the two wires are touching each other. This touching of the live wire and neutral wire directly is known as short circuit. So when the live wire and neutral wire are touching each other, it is known as short circuit. When the two wires touch each other, the resistance of the circuit is very small. So the resistance is very small. You know that B equal to IR, R equal to V by I. So when the resistance is too small, the current flowing through the wire is very large because the resistance is directly inversely proportional to the I. So when the two wires are touching to each other, the resistance are very small, so the current flowing through a wire becomes very large and it keeps the wire to dangerously high temperature and fire may be started. Do you understand what is meant by the short circuit? If the insulation of the wire is turned means the live wire and neutral wire are touch each other. So when it touch each other, the resistance of the wire are reduced to very small. When the resistance is too small, the current flowing in the circuit is too large and make it keeps the wire dangerously high temperature. Due to that temperature, the fire may be started. And what is meant by the overloading? The overloading is nothing but, look at this image, there are the four wires are connected in the single socket. So the current flowing in domestic wiring at a particular time depends on the power rating of the appliance being used. If too many electrical appliances of high power rating, electric iron, water heater, air conditioner are switched on at the same time, when we switched on the electric iron, water heater or electric air conditioner at the same time, they draw extremely large current from the circuit. This is known as overloading the circuit. So when we are using or connecting the high power appliance at the same time, it draw more current from this electric circuit. This is known as overloading the circuit. Overloading can also occur in too many appliances connected to a single socket. See here the nearly 4 appliances are connected to a single socket. When the 4 appliances are connected to a single socket, it draw large amount of current from the circuit. Due to that, the overloading occur in the circuit. For avoiding overloading and short circuit, we have to use fuse wire in our domestic circuit. So due to the large current flowing through them, the copper wire get heated to very high temperature and fire may be started. When we connected the too many wires in a single socket, it will draw large amount of current. Due to the large amount of current, the wire gets heated and fire may be started. And what are the hazards of electricity or dangers of electricity? See in this image. So electricity is one of the most important and convenient form of energy, but its improper use associated with the following hazards or dangers. When we are using the electricity in improper way, we will face the dangers. If a person happens to touch a live electric wire, he gets severe electric shock. In some cases, electric shock can even kill a person. So you never touch the live wire because it carries for the 220 voltage. Once you touch the live wire, you get severe electric shock, or it can even kill a person. Short circuit due to the damage to wiring or overloading of the circuit can cause electrical fire in a building. So, due to the short circuit, because the short circuit in a overloading, the fire may be occurred. So, you have to use the proper connection and give the fuse proper fuse. Avoid short circuit and overloading. The defect in the household wiring like loose connections, defective switch, socket and plugs can cause sparking and lead to fire. It may be in a loose connection means immediately you have to call the EP man to correct the defectives. Otherwise you will face the danger dangers. So these are the hazards of electricity or dangers of electricity. And this is your homework question. The first question, what name is given to device which automatically cuts off the electricity supply during short circuit in householding wiring? And the second question, along with the live wire and the neutral wire, the third wire is also used in domestic electric wiring. What name is given to this third wire? What is electric potential of the neutral wire in a main supply cable? When does an electric short circuit occur? Fifth question, in household circuit, is a fuse wire connected in series or in parallel? The sixth question, draw a labeled diagram to show the domestic electric wiring from an electric pole to a room. Give the wiring for a bulb and a 3-pin socket only. You have to take your book and see chapter number 13, magnetic effects of electric current. You have to open the page. Electric generator. This is I already discussed in AC generator. And today I discussed about DC generator. For in your book they are not given any circuit diagram for DC generator. Just to refer the video and draw the electric circuit diagram for DC. The next one, 13.7, domestic electric circuit. You have to read this passage, then you will understand that what I discussed in the video. And the chapter number 13 is completed. The next class I am going to discuss the question and answer. Thank you for watching. Do the homework.